All right, lesson 6A is going to look at binomial probability distributions. So the first thing is being able to identify whether or not something is a binomial experiment. Okay, so there are 3 keys that have to be met to consider something a binomial experiment. The first is that it has to have a fixed number of trials. So whatever our experiment is, flipping a coin, rolling a die, pulling a card, any of those different probability problems that we've talked about, we have to have a fixed number of trials before we start the experiment. So we say we're going to do this 1 time, we're going to do it 7 times, we're going to do it 500 times. Okay, whatever it is, we just have to have that fixed number. Okay, and when we look at formulas, in any formulas for a binomial experiment, n is the number of trials. Okay, so n is the number of trials. In order to be a binomial experiment, there can only be 2 possible outcomes, either success or failure. All right, now, this can get a little bit confusing because the experiment could have more than 2 outcomes, but if we can classify them as 6 failure groups, then we can call it a binomial experiment. So, for example, if I were to roll a die, okay, there are 6 different numbers on that I roll. But if I say that anything less than 2 is a success, alright, so I will die and get less than 2. So 1 and 2 would be my successes, 3, 4, 6 would be my failures. So even though there are 6 numbers on my die, there are only 2 possible outcomes, 2 or less or greater than 2. Okay, and again, when we're looking at formulas, we call P the probability of success. So whatever your experiment is, whatever the probability of success is, and Q is the probability of failure. Okay, and then the third requirement for a binomial experiment is that the trials are independent and conducted using identical conditions. Okay, so if I'm going to flip a coin 5 times, okay, every time I flip that coin, whatever I flipped and got before doesn't affect the next trial. Okay, so flipping a coin is independent. That's why it's used as an example a lot of a binomial experiment. All right, so first example we're going to look at is I'm going to toss a fair coin once. Okay, let's see if that meets all of our requirements for a binomial experiment. Number of trials, n is equal to 1. We said we're going to toss the coin 1 time. Number of outcomes when I toss a coin is either heads or tails, so that's good. All right, and we can find P and Q, and because it's heads and tails, P is 0.5, Q is 0.5. Now, in this example, P and Q are the same. They do not have to be. They can be, but they don't have to be. All right, and then flipping a coin, like we already talked about, is independent, so this is a binomial experiment. Okay, so example 2, we are going to randomly guess a multiple choice question with 4 choices, A, B, C, D. So your typical multiple choice question, let's say you have no idea. All right, so you're just going to guess, just randomly pick one, A, B, C, or D. Is this a binomial experiment? Okay, well, the first condition is, does it have a fixed number of trials? And the answer here is yes. Okay, we have 1 trial, just 1 question that we're guessing on. The next thing would be the number of outcomes. Okay, and this is an example of like what I was talking about. There's 4 answer choices, A, B, C, or D. But your answer that you pick is either right or wrong. So in this case, there are only 2 outcomes. Either you pick a right answer or you pick a wrong answer. Okay, and so P and Q here, the probability of me choosing a right answer would be 0.25, be 1 out of 4. And the probability of me choosing a wrong answer would be 3 out of 4, or 0.75. And our guess is independent. We have no idea. We're just randomly picking one. So this is a binomial experiment. All right, example number 3. We're going to toss a fair coin 5 times. All right, we're going to toss a fair coin 5 times, and we'll say that heads is a success. All right, so this is a binomial experiment. And then we just need to figure out what N, P, and Q would be equal to. All right, so since we're going to toss it 5 times, my number of trials, or N, would be 5. I still have 2 outcomes, heads or tails, and the probability of each of those is 0.5. Okay, example 4, we're choosing 2 balls from a jar of 5 red and 5 green balls without replacement. All right, so what do you think, binomial experiment or not? Okay, the answer is this is not a binomial experiment, and the reason is our trials are not independent, okay, because I am picking the balls without replacement. So if we call success choosing a red ball, the first time I reach in the jar and I pick one, there's 5 red and 10 total, so my P would be 0.5. But then the second time I reach in the jar, there's only 4 red and there's 9 total balls in the jar. So 4 over 9 does not equal 0.5. So if P and Q change from trial to trial, then the trials are dependent, and that is not a binomial experiment. All right, and then last example here that we're going to look at, toss a fair coin until you get heads. Okay, so you're just going to keep tossing. Once it hits heads, your experiment is over. Binomial experiment or not? All right, the answer here is no. The reason is the number of trials is not fixed. So I might flip a coin and it might take me 3 times to get heads. You might flip a coin and it might take you 14 times to get heads. All right, the number of trials is not fixed, so this cannot be considered a binomial experiment. Okay, and last thing we're going to do for today is look at 2 formulas, the mean and the standard deviation. So I know it sounds a little weird, like I'm finding the mean of an experiment. Like what does that even mean? So in a probability experiment, another way to say mean is expected value, or how many successes can we expect in this experiment. So if I told you that I was going to flip a coin 50 times, and success was flipping it and getting heads, the mean would be the number of times out of those 50 that I would expect to get heads. Okay? Standard deviation. Okay, so the formula for mean, this remembers the Greek letter mu that we use as a symbol for mean. So the mean is equal to N times P, number of trials times the probability of success. All right, standard deviation. We'll talk some more later about what this actually means in context, but this little O with a tail looking thing, that's the Greek letter sigma, which is the symbol for standard deviation. And standard deviation is the square root of N times P times Q. So the square root of number of trials times probability of success times probability of failure. All right, and we're going to use those 2 formulas in your practice problems.